All right. So are you ready to get going? All right. So we've already been chatting a little bit. I feel like I know you all already. So for those of you who may not have been here when they did the intro or whatever, my name is Joe Brockmeier. You may remember me from such previous careers as openSUSE community manager. I'm a recovering tech journalist. I wrote for LWN and Linux Magazine and pretty much anything with Linux in the title that had money, wrote for them. And I've been working for Red Hat since 2013, been involved with Fedora and Project Atomic, and I'll talk a little bit about that in here. If you have any questions after the talk, or you just want to, as I mentioned before, if you have questions about jobs at Red Hat, I'm JZB on Twitter, easy to find, or just JZB at Red Hat. Just shoot me an email. So what I want to talk about today are a couple of things. I want to talk about the problems that we want to solve with containers, what containers are. Some of you may already be pretty versed in containers. I think this guy up in the back in particular. I'm going to talk about what Atomic Host is, and then I'm going to do a couple of demos. Now, I know that demos are typically like NASCAR. People don't go to watch a car spin around and around and around. They go to watch crashes. But I cheated. I used ASCII Cinema to do the demos earlier today, but I will play them back. But I will show you, yeah, I know, collected like, oh man, I wanted to see a laptop in flames.
That can be arranged.
Is. And I'll also show you a little bit of Cockpit. How many people have heard of the Cockpit project? Just a couple of you? Good. It's really cool, so I'm looking forward to showing you that. So let's go ahead and get started. So my usual audience, by the way, I usually speak more to commercial audiences, customers, and things like that. So for me, it's a lot of fun to speak to an audience of what I assume are Linux enthusiasts, right? Y'all run Linux not because you have to, but because you want to, right? Okay. I have been using, my clicker is just doing nothing. It was working a minute ago.
I think you jinxed it when you said crashes.
It knew you recorded the demos earlier.
Oh, you know what?
Record this.
Is that a Windows PC?
Oh! Nice. That would mean we reboot just like now. I need to update.
Yeah.
That's smoke. All right. Sometimes it takes a little while to wake up. All right. So the problem people have with containers, I started using Linux in 1996, back when a lot of the applications you wanted to use still required the make, configure, install dance, right? How many people have been using Linux since the 90s? Excellent, okay. First distribution, Slackware?
Yeah.
What's that?
It's my second.
SLS, was that your first?
Mandrake.
Mandrake.
Oh!
Okay, that's an interesting.
I was young and stupid.
That's all right, I'm old and stupid. It's okay. So the whole point of Linux has never been just to run Linux, though, right? You want to run applications, right? And my entire career working with Linux has really been about how do we more efficiently ship software for people to use, either on the desktop, in the business, you know, whatever. And as I'm sure many, if not all of you know, the process of getting software from a vendor or from an internal development team into production is sometimes a little harrowing, right? The problem is, you know, you have one team that wants to use the latest PHP and Nginx, and you have another team that wants to use the latest Python. Well, we can't put Python on RHEL 6.5 that's in production right now because your system Python and the Python that you want to use, they don't play well together, right? And there have been all sorts of things you know, that we've tried to do to solve the problem. It also requires a lot of expertise to configure software in production, or at least it has historically. it, requires expertise configuring things. For a while, we thought, well, we'll solve this with virtual appliances, right? We're just gonna ship virtual appliances, it's gonna solve the whole thing. You spin up something on VMware or KVM, you're good, right? Except 2 months later, you find out that all of your software vendors use a different distribution that are all on different development cycles, and now your team are managing 40 VMs, all different Linux versions, right? One ISV is using RHEL, okay, that's easy. Another one's using Debian, okay. Gentoo, like you've got 40 different flavors now. How do you know when there's a CVE against all of them, right? So that didn't work. Solution, or a solution, is containers. Used to give a version of this talk, was whether containers were solving the problem or just moving it down the field or causing new ones. One of the horrifying things I saw when containers were brand new was people who knew about security, people who would never use like RPM find to grab a random RPM or grab a random Debian package from somewhere, like, sure, Docker pull anything, it's great, like I'll just run anything on my system as root. What could possibly go wrong? Yeah, you make Dan Walsh cry, So anyway, but containers are a good solution for some things. You load your application, quote unquote, at the factory and not at the dock when you're trying to get it into production. A couple weeks ago, I was at FLOC, the Fedora Linux Contributors Conference, and Dan Walsh was giving his kind of yearly address on containers and the work that his team was doing. He said something I thought was really interesting. People have been trying to think about containers as kind of a lightweight virtual machine, and that's wrong. Really, everything on your system is in a container. It's just most of the things on your system are in the host container. Because the constructs, and I'll talk about these, some of them, the constructs that we use to create containers are just kernel structures that exist that are just being repurposed to run containers, okay? So when you run a process on your system, it's in a namespace. It's just got access to the whole system. It's got C groups. You can set parameters for the resources. It's just that you're not really taking advantage of that and tuning it very much. If you're running on RHEL and you don't want to make Dan Walsh cry, you're running with SE Linux enabled, okay? Does everybody get the Dan Walsh SE Linux connection? I'm not sure if everybody. Sorry, Dan Walsh I work with very closely. He's kind of the guy who invented and shepherds SE Linux. And we all have SE, set enforce 0 and stuff like that shirts, or set enforce 1 shirts, anyway. So, it depends on who you ask what a container is. By the way, if you have questions, feel free to ask. I know we started late, so I'm talking a little bit fast, but I don't want this to be completely non-interactive, okay? Any questions so far? All right. So for applications, the nice thing about containers and the way that people look at them is it's a way for me to put all my dependencies, all those good things together, ship it out the door. Lets me deploy very quickly. I'll do a demo on my Fedora Atomic Host system in a little bit of spinning up Apache with single command, real easy, multiple instances in different containers. And it's easy to share components, and we'll talk a little bit about this. For admins, and a lot of the talk around Docker, I'm sure, has anybody here not heard of Docker? Okay. A lot of the talk around Docker is really focused on developers, okay? It's, the folks who invented Docker came at it from a very developer-y mindset. But the thing is, containers are pretty awesome if you're in ops as well, if they're done right. It's a lot, you can get a lot more processes running on a system in containers. They're portable across environments. They're not as portable as people think, but they're still, if you're running RHEL in your data center, you can easily move a containerized application up to AWS or over to Azure on RHEL, for example. Any questions? No. All right. If you have Googled the architecture of containers, it's probably wrong. The one that I see the most is you have this stack diagram. You've got Linux kernel, Docker, processes. as if the processes are running on top of Docker. Does anybody think that containers run on top of Docker?
When I think first about Docker, that's how it first started to sound like it, but after he, it was a present, actually I think it might have been the TriLUG presentation some years ago, but after a while, it was clarified that that the containers weren't running on top of Docker, but I think it's because Docker has its own virtualization, aliasing or grouping of sorts, but it basically it works with containers, but it's not, it's more like an interface to simplify it.
I like to think of it much like just a modified shell. I mean, Docker, yeah.
So what I've heard from the people, they got 3 people in the room, and one of them was a Linux LXC guy, and the other guy was a Docker guy, and I forget what big consortium, I think it might have been Google or somebody representing Case or something like that. They were discussing containers, and the only thing that Docker did, according to the room, was to simplify the API for containerizing your app. Basically, the C groups and the other namespace tricks to segregate networking and the file system from the rest of the users and then renumber the procs was all difficult to do in the original Linux environment, according to that group.
Yeah, so I mean, containers, well, I'll talk about the containers have been around for a long time. Easy to use containers have only really been around since about 2013. Yeah. So this is a little hard to read on a slide, but this is basically what's really going on. You've got the kernel and data structures at the bottom. You have your C groups and SE Linux, the drivers and everything else. And then above that, you have your user space processes and libraries working just as they normally do. The only difference is that you're calling and you're saying Docker or whatever you're using talks to the kernel and says, okay, this process or these processes I'd like to start in a special namespace. I don't want them to see the rest of the system. They should think that it's separate. By the way, we're going to use this root file system over here and networking separate over here, but they're still running on the same kernel as the rest of the system. The user space toolchain does, give you an easy way to work with things. How many folks have heard of Kubernetes? Okay. OpenShift? Most of you. Okay, good. I hope you're raising your hand. So we'll talk a little bit about, it may not matter so much what brand name you're using to run containers these days, because most people don't want to sit at a system and type Docker run something. They want to run 60 containers, and they want them to do all sorts of neat, all singing, all dancing tricks that are not handled by just Docker. They're handled by an orchestrator like Kubernetes or Swarm or one of those things. And this here just shows kind of the difference between VMs and containers. I think we all understand this at this point. Yes, no, pizza coma.
Do you just have API change root from containers?
Yeah, well, so change root, root is really very primitive. It's literally just starting. It's basically just saying start these processes over here as if this directory were the root directory. But it's not giving you much other isolation. It's useful, or can be useful if you're doing some packaging and things like that, but not if you really want isolation for applications, and certainly not for what most of our customers want to do, which is run, orchestrated. So one of my coworkers likes to call Docker or containers fancy files and fancy processes. Basically, you have your user programs and your library interpreter. The red indicates what's in the container space, and then the gray indicates the system calls and kernel space are still on the host. Okay. So what we've really done with Docker, or with containers, is manage to separate user space from the host space, and make it a lot easier to ship applications that don't collide with one another. And actually, when we talk about the files, they're actually layers. Okay, so all of these, and another thing that, you know, we came up with Linux containers is ways to layer things on top of each other. A couple of years ago, we had somebody from Yahoo come out to Flock and talk about what they were doing with containers, and they had, well before most of the rest of the industry, they had basically a system where one group comes up with the base operating system container. So they harden that, they give you, your development group, the operating system container and say, this is what you will layer your app on. And another group, for everybody in Yahoo, did Apache. So they would compile Apache the way that they wanted it, all the security, all the, you know, all the configuration options. They'd layer that on top of the operating system container. And then that would get passed on to different development groups. So you get a nice separation of responsibility where if you're a developer, you don't have to worry about the operating system. You only have to worry about the container that you're given and the layers below what you're doing. If that makes sense. You also can bind mount stuff that's already on the host, or you can, you also have copy on write with containers. So when you start up a container, one of the confusing things for me when I first started using containers was the difference between a container image and a container. Because a container image is not a container until it's actually started. And then you have, on the system, you have a container that's based on that container image as its root file system, plus everything that's gone on top of it. The copy on write file system, where if you commit it, you have all of your changes that are layered on top of that container, the processes that are running, and so forth. And here's the really confusing part. If you stop a running container, it's not an image anymore, it's still a container, even though it's at rest. So, any questions on that? All right. And then fancy processes. A lot of people, we talk about, we get a lot of folks who want to run, you know, hey, can we run Ubuntu on RHEL and have you guys support it? Well, no. Because while most of the time, now, like, if you're a friend of mine and you're like, hey, I'm running, you know, Fedora at home, but there's a container somebody else is making in the community on Ubuntu, can I run that on my system? Yeah, probably. That will probably work just fine. Can I run 600 of them in production for 10 years? No. No. Do not want to troubleshoot you in 5 years when you shoot yourself in the foot with that one and call up wanting me to figure that one out. Yes, sir.
What about all the people creating a small footprint OS as their starting layer, like Alpine, or even smaller microkernels?
So I was at DockerCon this year when they announced Linux Kit, and there were like two parts of me sitting there for that presentation. I started using Slackware in '96. Part of me was going, this is neat. This is really cool. Okay, this looks like a lot of fun to play with. The part of me that like talks to customers who are supporting things in production for financial services went, there is no way any large company is letting the Science Kit out into production. You know, yes, hi, ops. We've started compiling our own kernel and user stack, and we'd like to put that into production. Is that cool? Nobody's supporting it. You know, there's absolutely nobody but us in this room that is actually going to know the specific configuration of this kernel. Is that cool? So what do I think of unikernels? I think unikernels are largely interesting science experiments. It would take, for actual, so like if you're a university and you're doing HPC and you've got a bunch of researchers who can support that, I can see applications for unikernels where you've got donated hardware and resources and you really absolutely positively care more about performance than your sysadmins and developers' time.
So there's another direction.
Yeah.
You're in the HPC direction.
Yeah.
I'm in the embedded system direction. And
Yeah.
containers are moving down in the embedded system direction.
Yeah,
And you just cannot move giant operating systems into your containers.
Yeah.
Embedded systems.
that embedded systems are not a space that we're really looking at yet. Or I probably shouldn't have pinned yet. I don't know if we will. I don't want to imply that we will. But that's not a space where we're really looking. they do really funky things in embedded systems.
They
So,
have to fit.
what's that?
They have to fit.
Yes. Well, what I mean by funky things is that they're, historically, when I was at SUSE, I used to work with Greg Crow-Hartman, who, maintains the driver tree. And, got to hear many tales of woe about manufacturers and the way they do device drivers and things like that. And I imagine unikernels are the same way. They'll get developed up to the point where they get shipped in a device and never supported or touched again. And for a lot of hardware manufacturers, that works. As far as Alpine goes, Scott McCarty wrote a really good blog about comparing, okay, so the base size of Alpine is really tiny. Now add a web server, PHP, and your application on top of it, and suddenly it's not tiny anymore.
You can look at the libraries that get utilized and
Yeah.
dump all the non-utilized code from your libraries, and then it gets tiny again.
In theory. That's not necessarily something I want to put in production. But yes, those things exist and they're interesting, so. I think we've kind of covered this already, but if you look at the difference between a regular process and a containerized process, the basic difference is you're embedding it within a number of different kernel technologies. You can do things like, so you have one container, put something in your namespace, you can spread that namespace out to multiple containers so that it can share networking or memory or whatever. You can share other underlying abstractions here. So now I want to switch gears a little bit and talk about why atomic hosts.
I have a question real quick though. With the containers, so what's the level of isolation between it? So like can a process running in one container communicate to the other container across, say, the loopback port or some other network port or through a memory pipe or something like that?
It really depends on how you configure it.
But it's possible if you just configure it and set it up, right? They're not totally isolated. All right.
Again, it depends on how you set it up. You can basically apply about as much isolation as you want or as little, both from other containers and from the host OS.
Okay.
So a couple of years at FOSDEM, I did a very silly demo of how deep can I go with virtualization in containers, where I took a laptop running Fedora, atomic host and a KVM system, and then did a container with KVM and did nested virt, where I brought up another virtual machine inside a container running on that virtual machine, and then brought up another container. So you're like 5 layers deep. Not something I would do in production, but to demonstrate, you can actually use privileged containers that I'll talk about a little bit. You can use privileged containers or system containers to run things like KVM if you want the benefits of a container host without having to lose the ability to talk directly to hardware. You see a hand? Yeah.
Yeah, can I run, inside a container, run a application that uses X Windows or some other graphical and have it share that with the host
Yes.
system?
Yeah. Jim Perrin from the CentOS team a couple of years ago did a really horrifying demonstration of running IE9, I think it was, in Wine in a container. Yeah. Evil things, evil things. So why atomic host? So let me step a little bit back and talk about what atomic host is. Atomic host is basically a minimal footprint operating system based on either Fedora, RHEL, or CentOS, depending. With the idea that there are projects like CoreOS. One of the problems in my head these days is there are a lot of things like OpenStack and OpenShift and CentOS and CoreOS, and they kind of get all jumbled. So CoreOS came out and they were like, okay, we're going to have a minimal host to run containers on top of. Okay. The problem was that they basically invented an entirely new distribution that you would have to manage in production, where probably you'd be running virtualization and then CoreOS, and then something else in what I like to call the container filling, sort of like the Oreo filling, right? So that nice creamy center where the container is, you had to have a different user land from what was running on top of it, or under it, and then in virtualization. So you're like managing potentially 3 different operating system stacks again. So the idea is that we want standardization. The other part of this is that we want to optimize it and ship it out as an immutable host. I put immutable in quotes, not because I'm one of those people who doesn't know which things should be quoted, but because immutable is a concept, but it is not 100%, 1000% true. I'll talk about that. You get complete consistency between dev, test, and production. You can satisfy yourself if you're running 1,000 atomic hosts in your data center that all of them have exactly the same set of packages. That's hard to do if you're running 1,000 instances of, say, RHEL, due to update drift. If you've updated 50 at one time and 50 at another time, maybe those systems got slightly different RPMs because of when vulnerabilities were released. But with Atomic Host, you can know that, in fact, all of them are running exactly this commit of the operating system. Security, we use SE Linux control groups, we use setcomp namespaces to isolate and secure everything. Okay. The other thing is that you know the software. All right, we're already testing all of these RPMs with RHEL. The difference is just the way that we're shipping them. Okay. Any questions on that? Okay.
I have a question
Yeah.
from backing up a little bit.
Okay.
So would you say Atomic Host is very similar to CoreOS, but it's sort of like Red Hat's spin on that same problem?
I mean, they are similar concepts, certainly, yeah. So, that the only question?
Yep,
Okay, all right.
thanks.
So let's talk a little bit about what I call the anatomy of Atomic Host, okay? So first of all, the concept is everything should run in a container. When we announced this project and started working it in Fedora, I was kind of the community manager for it at the time. And I must have spent about 6 months beating back every request to like, can we just add this to Atomic Host to run on the host instead of in a container? Well, I'm a developer and I really want tmux on there, but then over here there's this guy that really likes Screen. Can we just put both of them on there? Oh, I really like this development tool. I really like this development tool. It's like, okay, it's now 3 gigs, okay? It's no longer a minimal host. The idea is that you run everything in a container, okay? So that you have a standard host with a very small footprint. The idea is you run all of your applications, anything you care about, in containers. With RHEL, for folks who care about Docker, we ship with a Docker and Docker latest. We basically have one version of Docker that we know to be good with like OpenSUSE and things like that, but we also try to ship a more updated version of Docker called Docker-latest. We also ship what's called a system container. This is a container that does not run using Docker. It actually uses runc and runs and can run as a system service using systemd service files before it starts. In fact, we have gotten to the point where we are shipping Kubernetes, etcd, and I think at this point for OpenShift Online, I think we've even containerized Docker itself. So Docker is not running these, it's actually runc and some other system services that run it, okay? And the idea is that you provide services that you don't want to put into the Atomic Host, into a container, but a different kind of container that has more privileges. Any questions on that? Okay. And as we've already said, isolating applications, in a container simplifies life for everybody. So you want to ship something with Python 3.7, and you want to ship something with Python 3.4, they don't have to fight. They can live in their own containers and everybody's happy. Image signing, because we care a lot about security and you make sure that your packages you install on a system are signed. We've started working on what we call simple image signing, which basically allows you to verify that an image that you got actually came from a vendor just the same way you would look at an RPM package's signature. But also we have a policy that can actually refuse to run containers if they're not signed with a key that you approve. So if you set a very strict policy, if it doesn't have, for example, the Red Hat signature, it won't run on your system. Okay. By the way, if you use RHEL, all the images in our container catalog these days are now signed. And we are pretty close to having OpenShift integration too. So where in OpenShift you can actually set policy, don't run any images that don't have these signatures. I want to talk about RPMOS tree. This is a really cool tool, and this is sort of at the heart of Project Atomic. The name Project Atomic comes from RPMOS tree's atomic updates. Anybody know what that means?
All at once.
All at once, exactly. So basically, yeah, it doesn't go boom. It's just that the updates are either they pass or they fail. There is a project in Fedora called Atomic Workstation that's actually using RPMOS trees as well. Not Docker containers, but it is using, oh shoot, what's the, it's like an IKEA type name, Flatpak, as containers for desktop applications. How many people have ever done, like, gone to a hotel and you're like, oh, the system keeps nagging me about this, update. I'm gonna go ahead and run the update. Oh, good. There went my Wi-Fi and I can't get the package to fix it because I just ran the update that killed it. RPMOS tree allows you to actually do a number of fun things, one of which I'll demo here. But it actually allows you to roll back to the last known good version. So, you run an update, something breaks, just roll back.
That's similar to CoreOS's model with user A and user B?
Yeah.
Same idea?
Yeah. You also get, it's sort of like Git for your operating system. It isn't exactly there, although we are getting closer to it. So each version has a commit. But not only that, you can actually rebase your system on a completely different tree. And I'll show another demo where I go from Fedora 26 atomic host to Fedora 26 testing. So basically, instead of just, and you could rebase, and I have done this before, you can take a Fedora system and rebase to CentOS. You can take a Fedora system and rebase to RHEL. Anything that's in OS tree, basically, you can rebase to, and keep the same user, land, and containers and everything that were already on the system. It is an immutable OS, so if somebody installs a container on your system, it doesn't make changes to the system itself. It runs in that container, okay, and it reboots, anything disappears, okay. We do, however, have the ability to layer packages on Atomic these days. Reason for that being, we don't want you to layer a package on for an application. You still should run that in a container. But some folks want to run monitoring agents, or they want to install kernel modules or something like that. They have hardware that they need to support that we don't support right out of the box with RHEL. And that will allow you to take an RPM and layer it on the system, and I'll show you this. And as of 7.4 for RHEL, and earlier than that for Fedora and CentOS, we have what's called LiveFS, which actually allows you to apply new packages without a reboot. Now it's not for updates to the system, so it's not for like, oh, I pulled down some RPMOS tree updates and none of them are the kernel, so I could just apply all of them. No, it's specifically for applying like new packages, okay? Because it's kind of a bummer to just install a package and have to reboot your system, right? So there's also the Atomic CLI for, it's a cohesive entry point to Atomic. So if you are working with single or just a couple Atomic hosts, you can use the Atomic CLI to pull containers. We do a nifty trick where we use the label for the container. So how many folks have actually used containers and done like the really long string where you've got to say, okay, mount this, and give it this networking and this, like, by the time you're done, the CLI is this long. Okay, so you can actually, like if you're a dev and you're configuring things, or if you're an ops and you're getting things ready to go in production, you can put that in the container label, and then you just atomic run, and it reads the label and applies all that from the get-go. So you don't have to type that every time you run a container. Does that make sense? We also have a diff tool where you can take a version of the container and look at it against another container, and it'll say, oh, these RPMs are different, like these things have changed. And you can also use Atomic Top to see what's going on your system. And if we have time, I'll probably show that. And there's also an atomic scan tool that uses OpenSCAP, or if you're a Black Duck customer, there's a plugin for that. That'll actually look at your container and say, hey, like these CVEs seem to have come out against this container, you may want to update it. Okay? Any questions on that? Pretty straightforward. Is everybody still interested, or are you just being really polite? That wasn't a yes or no, really.
No, I'm interested, yeah.
All right. And I will mention satellite. One of the nice things, if you are a RHEL user, presumably if you're in a large-ish environment, you're probably using satellite. Satellite 6.2 supports atomic RPMOS tree content. It supports containers, kickstart images, and all these other things. So basically, it is now well designed to handle not just regular RPM content and ISOs and things like that, but it's now able to handle atomic OS tree content and containers. And then there's Cockpit, which I really love. The folks who work on this, a guy named Steph, came up with this. They have a great community. Like, you go to them and you say, hey, it'd be really neat if Cockpit did this, and like a week later, like, hey, remember when you mentioned in the hallway that you'd like to see this feature? It's done, come check it out. That's not a guarantee, but they're just like super user-oriented. They're super nice. Everybody remember Webmin? So
Wow.
Cockpit
Now I
is
feel-
basically, what's up?
Now I feel old.
Yeah,
There is a special help for Webmin.
So Cockpit is Webmin done right, okay? Cockpit is multi-system, or it can be. You can run it on a single system. You can also point one Cockpit web interface at others and manage them all through a single instance. And it lets you do probably, I don't know, 30–40% of the stuff that you would want to do with a system directly from the web interface. Start and stop containers, manage storage, check for updates. You can even run OS tree, host updates from the Cockpit interface. A couple things to mention with RHEL 7.4, that's the latest version of RHEL that's out. We have moved to full support for OverlayFS for containers. What OverlayFS gives you is, so for example, if you're building new containers, if you're using OpenShift in production, you're building a bunch of containers and pushing them out in production, it gives you faster Docker builds, things like that. Because basically what you're doing there is you're taking one image and just overlaying your changes on top of that. Package layering is now supported, so installing new stuff is fully supported, but the live FS is still in tech preview. Container signing is fully supported. Also, we have an SSSD container for people who want, I'm blanking because it's late, IAM, identity management. As I mentioned, all the container images are signed. We also have the container health index in the Red Hat container catalog. So like if you're a Red Hat customer, you go in there and you look, at a glance it shows you like this image was, has no vulnerabilities and has been updated in the last 30 days. It's an A. God forbid, but like this image hasn't been updated in a year and has 5 critical vulnerabilities. It's an F, and you know that just at a glance. And the container catalog also gives you just tons of information about the images, how to run them using OpenShift or Atomic or Docker, or I think there was one other one. It also gives you information on like all of the packages that's in that image. Usually there's some documentation on how to run it in production. And the final thing I wanted to talk about before getting to demos, I think. So we've been working upstream on a couple things. So the first one is called Cryo. So I don't know if folks have followed, Kubernetes last year introduced what they call the container runtime interface. The reason for that was Kubernetes and Docker used to be basically welded together when it would go into production, which meant that, surprisingly, 2 open source projects move at different speeds, and if you depend on Docker and they change something, you break, which is bad. And it held back the Kubernetes community from doing things, and it made things difficult probably for Docker, because like Docker would push out a new version and they'd get a bunch of bug reports because, hey, you broke my Kubernetes. So what they did was they came up with a runtime interface that basically allows an open interface to communicate between the container runtime and Kubernetes. So that also opened the door for other container runtimes, like Rocket, because they wanted to be able to support Rocket. Clear containers from Intel. How many folks have heard of those? Intel's clear containers are basically a way to run containers as a virtual machine instead of as actual container. It's kind of nifty technology. It's lighter weight than your usual virtual machine, although still a little bit heavier weight than a container. But it also lets Intel show off all their hardware extensions and nifty things they can do with virtualization on a system. I don't know that clear containers are ever going to be like widely commercially used because Intel, as far as I know, they don't sell support for it or anything like that. It's a fully open source community project at this point. But anyway, the point is that all these different runtimes can work with Kubernetes as long as they adhere to the CRI and they pass those tests. So what we did was we've been working on what we call CRIO, which is basically a daemon for working with OCI, that is Open Container Initiative, compliant images and runtimes. So the idea is that, again, you can swap out run C, which is what Docker and everybody else basically uses to run containers, or for clear containers or Rocket or whatever. So the idea is that if you're running Kubernetes, if you're running containers at scale, you probably don't care a whole lot about what's on the system that actually talks to the kernel to run the container. You care about orchestrating 5,000 containers in production. Okay. There's KPod, which goes along with CRIO, which is basically just an interface for having a runtime interface that just works with Kubernetes is great. But sometimes you have to like log on to a pod and actually find out, or a node and find out why something's breaking. So it's a command line interface for CRIO, basically. And then there's Builda, which is basically a builder tool for OCI images. Builda comes from, again, Dan Walsh's team is the one that works on that. Dan is a Bostonian, and so he pronounces builder as Builda. Dan is also the guy you may have seen who, you know, DACA is, anyway. I'm going to skip this, yeah. That's the container health index right there. I do want to talk very briefly, since you brought this up. So for RHEL we have, and for Fedora and CentOS, we have a standard base image, which is not petite, it's about 200 megabytes. It's a standard RHEL lifecycle image. Basically, we preserve the major, minor versions, and it uses the Yum package manager. However, if you really want a small image, like say you're shipping something into production using Golang, and you don't really need like Python support, you don't need RPM support, things like that, you can layer it on top of, if you have Java binaries that you just want to throw onto something. It's a 28 meg compressed, 78 meg on the system image. Now it only follows the latest release, and we've removed most of the components that you don't need, and we've also replaced DNF or Yum with microDNF, which is a C-based implementation of the Yum/DNF protocol, and also doesn't have SUID binaries. Any questions on those? Okay. We can skip past that. All right, so real quick, I wanted to do just a couple of quick demos to give the flavor of RHEL here. All right. I'm going to set up mirroring here because I find it hard to type over my shoulder, so just bear with me a moment. Where is my mouse? It's got to be here somewhere. There we go. Hey, all right. Great. All right, can you all see that? Do I need to embiggen it?
Might help to make it a
Big,
little
big.
bit. Yeah.
Better? All right. All right, so the first one here.
Blade.
There we go. All right. So what I'm going to do here, or what this is doing, is we're going to layer a package on. So I'm going to put wget onto the system. Now I don't want to reboot. By the way, one of the reasons I did this because I wasn't sure the bandwidth would cooperate to do this as quickly. So RPMOS tree EX is for experimental feature. LiveFS, I've gone ahead and added it. And now you see we've got a new commit with a live commit version. Again, this is a lot like Git for operating systems. And there you can see now we have wget on this system, okay, without having to do a reboot. I know it's not terribly exciting, it's a command line thing, but this is actually very useful.
It's for a live production.
What's that?
So for a live production server that, you know, has 10 million people using it, and you need to install that one little application or patch, yeah, that's a kind of a lifesaver. That would have made my life a lot easier about 15 years ago, 10 years ago.
Now this one here, I'm going to show a rebase, which is basically we're going to take and move a Fedora Atomic host from Fedora Atomic to 26 testing instead. By the way, I really love this tool. ASCII Cinema is awesome if you haven't tried it before. It even captures your mistypes too.
Is that acting like a rubber ducky, or is that it's playing back runs that you've done earlier?
So it's playing back what I've done earlier, but it's not actually doing it again to the system.
Okay.
Yeah.
So
So it's a simulation.
Yeah, exactly.
You can freak people out with that, so much fun.
Yeah. RM-R, yeah, you could.
Totally make someone like go berserk and
Oh, no.
murder all their coworkers. Yeah.
Sorry, Bob, I didn't mean to delete the production database.
We'll look at it up.
You all are evil. I'm just gonna put that out there.
We love our coworkers.
I'm a container, worse than a container neophyte. I've only used one once. So
Okay.
I'm missing the whole thing about, okay, you installed wget and you didn't have to reboot. Well, the last time I installed wget, I didn't have to reboot either. Why would you have to?
Sure, that's actually a reasonable question. So as I mentioned before, the idea for RPMOS tree though is that it is immutable.
Okay.
And so the idea is, you know, I ship you the OS image and that's it. You don't make any changes, you just pull down updates. But we found that there are a lot of customers who needed things that they actually could put on. So that's why it's kind of a big deal for this, is we're actually making changes to a different kind of file system.
Okay.
Yeah. And yes, you know, like if you're just running RHEL in production, regular RHEL, you can install a package, it's not a big deal.
Are you making changes to a read-only file system layer? Is that?
Yes.
Okay, so you're adding an extra layer without restarting the whole stack.
Exactly.
And that goes to your comment about reboot and so on, so you come back and you're back to your original.
No, so in this case, when you reboot, it's still there.
Okay.
It creates a new commit. And I don't think I mentioned this earlier. So, I mean, it's taken a while for Colin and the team to implement this because they're not just layering the package on there. They're going to track that package and keep layering it on there for basically eternity, as long as they can, which is some pretty heavy food. So, okay, so you can see here we've gotten to switch to testing, And now you see that I've gone from one ref, the one at the bottom here, Fedora Atomic to Fedora Atomic Host testing. So it's basically like switching, if you use Git, it's like, for example, creating your own branch. And one of the things that they're working on, I can't promise this will ever make it to, RHEL, for example, but one of the things that they are working on is making it where you can actually commit a tree. So if you make changes right now, there are tools upstream to create RPMOS trees. And I've done this before where you basically, create your own package set and ship it as an RPMOS tree. But this would give you the ability to basically create a golden image with, say, wget or whatever, commit it to a different repository and have all of your other hosts pull from that, if that makes sense. So it's basically like literally you're able to commit the operating system you want everyone to check out, okay? And that's the end of that demo because once you reboot, ASCII Cinema stops working, so. All right.
Question.
Yes, sir.
I'm running hundreds of, or let's say I'm running 100 Docker containers or whatever containers, and I change the base image, I add wget to it. Do they all get that immediately? The ones that are running?
Ask me that one more time, please.
So we just added wget to the base image,
Mhm.
Do the other containers that are currently running with that base image get wget
Oh, I see.
at the same time?
No, this is actually to the host, not any of the containers.
Okay.
Yeah. So,
But would that be possible to do something like that?
no.
What good are you then?
What's that?
Because that's the difference between a container image and
Sure.
a running container.
So, since containers are layered and since their containers are immutable, and since we've had DLLs and virtual storage and shared objects around since time immemorial, how come layers can't be stored as a virtual object that could actually be layered and referenced in a container instead of every container having to contain all the layers?
I'm not sure if I followed that question, actually.
Okay? So what we do when we construct a container is we go get a base image,
Yeah.
we lay it down, then we go get somebody else's container, some Nginx or whatever, and lay that down, and then we go and customize it some more and lay that down, and then we, put that package in a Docker file, or we actually save that image, and that becomes an immutable object that we have to load into memory and save as a file system like that, with it taking up memory and taking time to load. Why can't each of the layers be independently stored as layers and referenced in an object that refers to a base image as a layer that it's dependent on?
They are.
That's what it's on.
That's what Atomic,
Yeah, it's basically a core system that the containers rely on.
I don't think Docker does that.
Yeah, it does. So as long as you don't remove the history, like if you give me a base image and I do something.
So it's composing the image of layers of virtualized file system.
Yeah.
Yeah, so
And so
doing
like,
system calls and kernel calls.
So I always,
this is one of the dangers with Docker, if you're not careful, by the way, is like if you're doing things manually and you say, well, at this stage, I'm gonna insert a few secrets and then I'm gonna do another commit and remove them,
Right.
they're still in that layer.
But, so you're saying when I create image one,
Yeah,
container one, that has layer A
Yeah.
and layer B and then layer C1,
Yeah.
and I create a container two that has layer C2, that the A and B are exact copies of the original, and that file system that's essentially a tarball is gonna be only one place on the disk.
yeah.
Yes, if you have
Yeah.
10 Docker containers that all use the same base or vector image, which happens all the time, then you have one copy of your base image.
Yeah.
Yeah, you only download it once,
And-
and then it's applied to all the others.
And then if you run that image and you make changes and you save them, it's only saving the copy on write layer. It's not creating, it's not,
Saving the copy on write layer.
yes,
Yes.
so, Yes.
And to take that a little bit further, where you really get the mileage out of that is if, like in my office, we have a 4 terabyte database, and all of us need a copy of it to run our tests. We only have one copy of that large database, and each one of us gets a layer on top of just the rights that
I
we applied
assume
to
the
it.
database is also immutable. 'cause they
Oh, well,
don't
that layer is immutable because we all get a copy of, a snapshot of whatever the database was, like last night's copy.
If you can make changes to something else, then that only creates a delta between that and the original image. Like Docker pulls a container based on the
Docker's very much like Git.
Yeah.
Yes.
Somebody, so they've described it to me as more like a tarball, and then you say, oh, I've got a layered tarball for each of these images. And you go, oh, okay, well, it's not efficient.
No, it's not. It's not a tarball. It's like basically a template.
So what I did there, I just started up Cockpit, and you'll notice that I used atomic run instead of Docker, but what it did was it shows the label that I just ran. And because this is accessing the host system, it's actually showing that it's a privileged container, and it gives me info about the switches that I just used.
Just like invoking run C directly?
Sorry?
Atomic run is like invoking run C directly?
Well, it's actually, in this case, it is using Docker.
Okay.
But it's running it as a privileged container,
Right.
not a system container, a privileged
Privilege,
container.
gotcha,
Yep.
thank you.
Yep.
So it's that verbose by default, basically?
Yes.
Okay.
I'm just spinning up a couple of additional containers here. Hilariously, I've forgotten the key sequence to get out of full screen here.
Control,
There we
Alt,
go.
Delete.
No, it's Alt F4.
Oh, yeah, Alt F4. You're right.
You all think you're funny.
Control
Yeah,
system
that's-
break.
We're still
That's
waiting for,
press the command key.
we're still waiting for the
Shift.
plug.
Command option.
Come on.
And then it creates a
Control
Microsoft key.
Nope.
You turn it off and on.
It's not letting me hit this. Yeah, I know, right?
You jinxed yourself.
I did. No. Nope.
Don't worry, this only ever happens when people are watching.
Yes, that's right. All right, seriously, if anybody knows escape there for,
Control Alt, and then you're supposed to give it to the little button. Hit Control Alt at the same time.
Okay.
Control
Okay.
Alt, Control F double.
That's what Fedora project says.
what was it again?
It says to exit full screen mode, you first need to press Control and Alt combination, then mouse arrow will appear allowing you to select the leave full screen at the top center of the screen.
Ah.
I think it was a left control and left double keys. There you go.
Just hold down Control Alt at the same time.
Yeah. It is. There's a T-shirt that shows you how to exit.
There we go. You know what's funny? How many folks know John Hall, John Mandog Hall? years ago, he wrote a Linux for Dummies book, and they forgot to put how to exit BI in the BI section. And, yeah, they got a lot of complaints.
Did they forget intentionally?
No.
That explains it.
There we go. See that? All right, excellent. Okay, so this is Cockpit. And so I'm logged in there. Let me, it's going to get real chunky. You should be able to see that better. Okay. All right. So if you log in here, for example, I can see all the containers that are running. I spun up not only the Cockpit container, so I'm actually interacting with the system through the container, but I also spun up a couple of Apache instances. And you can see those are all running. I can manage those from here. I can even stop them if I want from here. I can pull down new images from here. And you'll see too, for like Rel folks, for example, if you're using a supported scanner like openSCAP, this will even show you if you have current vulnerabilities. So this is a pretty usable interface for folks who are, for example, if you want to give limited access to a system, you can give somebody just enough permissions to run containers and log in by this. So they don't have to shell into a system. They don't have to have access to everything. They can just run containers from a web interface. So if you're in a small shop and you're not running thousands upon thousands of containers, this might be a good solution, for example. It's also nice to use on your laptop if you're running these kind of things. So that is pretty much it for the demos and everything. I promised I wasn't going to talk forever. Does anybody have any final questions or comments or thoughts?
You mentioned OpenShift a few times.
Yeah.
Is this a first-class citizen as far as OpenShift is concerned compared to RHEL?
This being, yeah, so RHEL
I've heard that it's not quite.
So previously, that was probably true about 8 months ago. It is no longer true. So it's now, it's fully supported. They do have.
So if I'm going to kick off an OpenShift install, I can go ahead and do a fully containerized install on Atomic, and I should be very happy with the results.
It is, yeah, it's now supported.
Promise.
Yeah.
Thank you, promise.
So, other questions? Yeah.
Like the gentleman here, so it's a little bit over my head that I will ask. With AWS or Cloud Cloud, whatever, what's their SLA, whether they give you a container or a VM? Or just, can you talk to that at all?
Are you asking, so if I go to AWS, are they giving me a VM or are they giving me a container when you run an instance?
Yeah, or just the discussions around questions like that. I mean, it seems like, I'm sort of stuck on this idea that containers is lightweight VMs.
Yeah.
So I need to understand better why that isn't true, but for the sake of this discussion, let's just sort of pretend that it is sort of true.
Okay.
And then if I can go get a VM at AWS or whatever public cloud, or however that stuff works in detail, with the advent and evolution of containers, it seems like it's in their interest, for the reasons that it's in everyone's interest to run containers or use containers, to put as many people as possible in containers for their own sort of financial.
Yeah, but AWS, so
don't get, I'm not married to it.
Well, they'll give you an overloaded instance. They have no problem doing that.
Well, so AWS, their stuff, if you run the EC2 or whatever, that's based on Zen. So they are giving you VMs, or in some cases, I think they have EC2 instances that are dedicated hardware. I'm not even sure if there's any virtualization.
But just
there
the
at
general
all.
idea, how does this affect that business model? Does
It doesn't, because they are guaranteeing you a certain amount of CPU shares and other things that are not
sort of
good to containerize, yeah.
Just thinking out loud, this would actually benefit the consumer, not necessarily the provider.
Yeah,
So whereas a VM costs you X, the containers would cost you Y, which
Yeah.
should be a fraction of X.
now, the nice thing about containers, like let's say you were a customer of Linode or one of those folks. Previously, before containers, if you want to run 3 or 4 different versions of something on your thing, you would end up having to spin up 3 or 4 different VMs. Now you can just get a decent sized VM from them and run your applications containerized. So you can partition up that VM however you like.
So yeah, you could have containers running on a Linux system that was running on an AWS instance. So because like anything alone, it's not a true virtual machine because you don't have that level of separation. They're all running off that same kernel. That kernel crashes, it's all on.
And the other thing with Docker type containers, the idea is to run these as microservices. So like Docker and other runtimes that are set up for Kubernetes, those are not designed to run full systems. They're really designed with the idea you have one thing running in your container. Now there are things like openSUSE and Virtuoso that do set up VPSs that are containerized rather than hypervisors. But those are, like your providers are usually pretty explicit about whether you're getting KVM, openSUSE, or Zen. So, yes, sir.
I don't know if you really covered this. How do I configure this? How do I deploy this compared to RHEL?
Same.
How do if it's immutable, where do I set hosting and networking and VLANs, and how do I set up my storage? And normally I do that with Ansible or a Kickstart or something.
No, it's
cloud config or?
Well, yeah, you can use cloud config, but okay, so like the network settings and things like that are not immutable. What we're talking about is the package set being immutable. So you can still set networking and things like that using Kickstart or Ansible or whatever. So that one of the advantages of using Atomicos versus other things is that if you, as a company, have already invested in tools that work with RP, like with RHEL or RHEL-like systems, they'll work with Atomicos.
Because is it installed the same way? Is there still the same mechanism?
Yeah.
Okay.
So you can Kickstart, you can do Pixie Boot, we ship QCal images, we ship raw images, we ship a bunch of different things. AMI, you go to AWS, you can spin up Atomicos. So yeah, all that stuff. Gentleman in the back still got? Nope. All right.
What's your resource commitment for each container?
Well, it varies. It's kind of like asking what the resource commitment is for a process.
Meaning overhead.
It's like running a process. So there's really not overhead. Very minimal. I think there's if you do a Google search for something like that in Jeremy Eder, E-D-E-R, he's done a couple of blogs that I think are public about different performance tests we've done, where you can, like how many containers can we spin up on a system, and what impact and overhead. It's very minimal. Now, like these days, KVM and Zen and all those, they also don't have as big a footprint as they used to, but there's still a decided difference. So, I saw a couple. Yes, sir.
So having lots of containers should increase the amount of IOPS, right? Because you're essentially duplicating libraries and then reading them multiple times, right?
No, it's going to be cached. That's going to be cached.
Okay, it's cached.
You're not going to hit disk that.
Okay, and the question that I had was, how granular is the control for system calls and access to kernel level stuff? So there's specific modules that a Docker container might need, or any container might need. How granular is that level of administrative control to deny resources to certain types of containers?
It's pretty controlled. There's drop capabilities. Dan Walsh did a really good blog about all the capabilities you can drop from containers, which is most of them. There are a couple of things, I forget which capabilities off the top of my head. There are a couple of things where you will probably run into some headaches if you drop those capabilities from a container, but for the most part, you can drop like half of the privileges you would normally give something. So you can get fairly fine-grained. You can certainly get as fine-grained. Anything you can do with like C groups and namespaces normally, you can do with containers, SE Linux, those sorts of things. So pretty darn fine-grained.
And modifying the kernel when in the core image, is that something that's really not supported, or is it, this is the base image, this is what you're expected to run, and then you're not supposed to really add a lot of modules or modify those modules without going through the normal repository for that?
Container is still running on the host kernel.
Yeah, containers are running on
That's what I'm saying,
the
the host
kernel.
kernel, like what's the host kernel control like for the end user? Is it, they just accept the core
Yes.
host kernel and that's it,
Generally
or can
speaking,
they
yes.
modify that?
Yeah, like if you're a user, you shouldn't be inserting kernel modules or whatever.
Okay.
Yeah. So.
Bad user.
Now, what's that?
It's a bad user, no donut.
Well, bad sysadmin if you're letting your user.
Yeah.
But what I meant was the end product user, not necessarily the end user.
Yeah.
Yeah. I
So
meant
you.
admin on here.
The admin can insert, like with system containers and whatnot, you can insert kernel modules if you have to. You can install, system containers or RPMs that have monitoring agents and things like that. Obviously, like if you're a RHEL customer, so if you're a RHEL customer and you usually use hardware that has supported like kernel modules, then you'll be supported. It would normally be supported on RHEL. If you are trying to swap out the whole kernel, we're not going to support that. Same as if you were just running regular RHEL. So most of the same rules apply. Yeah.
So, so Atomic Host is mostly a container management solution, from what I understand of it. So it's something like, if you were using Docker instead, if you're using Docker or like Docker Compose instead, you'd be using more of this. Is that a fair assumption or no? Probably not. Okay.
Probably not. No.
Okay, so so I guess the question is like say I wanted to spin up a Atomic Host server with, using containers to provide services. Now, is there like networking support? What kind of networking support like that? Can it run as like say a reverse proxy and reverse proxy a bunch of services, or like how would that be handled? Would I have to set up something like Caddy or Nginx to do sort of that?
Well, you could run Nginx or whatever in a container on the host and set up those services.
Okay, that answers my question.
Yes, sir.
Okay, I think it gets back to the container per se. Privilege and mounting network PowerShells directly.
No, you do it in the host. You want to do it in the host.
Sometimes I don't want to mount the thing on the host because I don't want the host to have access to something else.
Well, the host, no.
The host is always going to have access.
That's not a thing.
The host is always going to have access to it. If it's running on the host, it has access.
Okay. So that means it can escalate?
Yeah, if you want separation like that, you're going to have to use VMs for different systems. You can't use Docker and stuff like that.
Well, and even if you're if you don't trust the host, don't run on anything on it that you don't want the host to be able to access, whether it's a VM, whether it's a container, or a regular process. I mean, if you don't fundamentally trust the host or the users on that host that have host-wide access, then don't run it on that host. I mean,
It's more a case of, you got the host, you're separating access from the containers. Not all the containers can see everything.
yeah. So container A and container
Think of the host
B.
as your OS, right? Don't think of it as a box.
Yeah.
Think of it as your OS.
Container A and container B should not be able to see or interfere with each other unless you specifically try to put them in the same namespace and they need to work together. But you shouldn't run container A or container B on a host where you don't want someone to be able to see what they're doing, because you run top and those processes still show up.
But see, on a user case I have is, if you have a PowerShell that requires authentication, if you put why the host, but then, and you have container A needs a PowerShell, container B needs a PowerShell that's authenticated to completely different systems. That means the host has to support both authentication systems to mount things.
No.
You shouldn't have to mount it at all, like you set up, I mean, if you're saying running like, say, a Samba share on something, you could run a Samba server in a container.
Yeah.
And just open the ports you need. So say you were running two containers, like you were saying, Samba server, Samba client. What you could do is you could bridge those networks together so that they could see each other. And then, whoever was using it from one container could log into the server on the other container, and it wouldn't have, I mean, the host would still be involved in making the connections, but the host itself would not be connecting to it.
But in your case, the Samba server is on the container, but what about if I'm getting something from storage somewhere?
Well, I mean,
It comes through the host, all right? So if I think of it as a pipe going from your container to wherever you want to go, it's just.
Because see, the way I see it is like you have to mount the file share on the host, and then you pass it to the container.
Yeah, so it's.
So the host has to be able to
you would think
authenticate as the user in the container that needs to have
No,
access
it's
to
just
things.
passing the authentication to you on the container.
Yes, but then the host has to know the authentication too.
No, it's just you on the container.
just
So it's like, your host and you're here, and your storage is out there, all right? It just kind of comes through to you. It doesn't do anything with it in between. You're the one doing something to it down here.
But now we can talk later because I still don't agree.
I'm gonna let you research that one on your own.
I've done, and I could never get an acceptable response. The only reply to do what I want to do, I have just got a privilege on the container to mount the file share directly to the container, so it could authenticate at the container level, not at the host level.
There are occasionally use cases that are not easily satisfied by any existing technology. So I'll leave it at that. All right, any other questions? Yes, sir.
So on Realm, the kernel seems to be tuned pretty well for network throughput, whereas on a lot of the Ubuntu stuff, it's not necessarily that way.
Thank you.
So is Atomic is similar in that the kernel's tuned for Mac throughput?
Same kernel.
Okay.
Yeah, same kernel, same tuning. So, the only difference to that would be that, so we do configure Atomic Host specifically to use LVM for container storage and so forth. So there's a slight difference in terms of the way we set up storage out of the box, but that's basically it. As far as networking and other variables, all the same stuff. So let's see, the gentleman in the black and yellow, or the blue and yellow shirt.
Yes, I heard a while back that containers are not really something that we would use for actual security isolation. Has that changed in the last couple of years?
It has changed dramatically. If you really absolutely positively for sure cannot tolerate, any lack of isolation, I would still recommend using a VM. But I would say we're like 97% of the way there with containers, but it isn't as full as isolation as, say, as a virtual machine, or as having two separate, completely different hosts. So, you had a question too.
Yeah, I was just curious about the overhead with the RPM tree and that sort of thing going on in the system. Like, you were keeping like a full commit history of all the containers and packages being overlaid on top of the Atomic host. I was just wondering how much of an overhead that is. Like, you got.
It's really not. It's not like it's something that's always running in memory or anything. And I should point out that you don't keep like every commit ever to the OS tree. Usually it's two. So you keep the current running one and the rollback. But you keep the configuration so that in the future, like if you do an overlay, it knows that yes, I need to make sure that we keep wget or whatever it is.
So how far can you roll back then?
Well, as currently configured, you get one rollback.
You get one rollback. So
Yeah.
the immediate last transaction.
Yeah.
can be
Now,
rolled back.
you can rebase if you know a commit and you have a repository where they have all the commits. You can actually rebase to an earlier one if you know specific commits.
Okay.
But as far as like what's actually kept on your system, because obviously over time, it would get very big.
Yeah.
It's not too bad, so. All right, are we, all right, yes, sir.
I'll make that the last one.
Core OS that uses etcd and has no mutability of configuration on the system?
So actually, like just about anybody who's using Kubernetes is using etcd. As an upstream project, it's pretty widely adopted.
Okay, so there's a lot of configuration in etcd.
No, etcd is configuration for like your containers and apps and information, not for the system itself. Although, so the way that CoreOS, as I understand it, I don't hands-on do a lot of CoreOS work, but as I understand it, they do also do like some configuration for their systems using etcd.
That was my understanding, is that they, it's pretty much a fully immutable OS.
So, all right.
Thank you very much.
No problem. Thank you.